All right, last thing we need to talk about in this section is one-to-one and onto, and discrete and continuous. So these are special types of functions um, that they like to be able to describe them in this way. So a one-to-one function, you can read the definition there, is where each element pairs with exactly one element in the range. So basically it means that you're not going to have like two Coke buttons on the Coke machine. All right, every button has exactly one type. So there's one Coke, one Diet Coke, one Coke Zero, one Sprite, one Dr. Pepper. All right, you don't have a repeated. So the way that you tell this is no repeated y values. So just like a function is no repeated x values, a one-to-one function is no repeated y values as well. Okay, and if you have a graph, you can do the horizontal line test to test that out. Okay, onto just means that every element in the range corresponds to an element in the domain. So basically there are no elements in the range that don't have a corresponding x value. We don't really encounter very many functions, if any functions at all, that are not onto. So just assume they're onto, and if we do encounter one that's not, I will definitely make a point to point that out to you. Then discrete versus continuous. Basically, discrete means it's a set of points that are not connected. So if you just have a graph with a bunch of points on it, that's discrete. And continuous is like a curve or a line, something that connects everything together. So the way that I always remember the difference is discrete cannot be graphed without picking your pencil up off the paper. A continuous graph, you can graph the entire thing without picking your pencil up off the paper. So we will encounter a function that is discrete, that we have to pick our pencil up, but most of the functions you've seen so far and the ones that we're going to be covering here early in the year are continuous. So to go along with this, I have one more thing. I want us to graph each one of these, determine if it's a function, one-to-one, onto, discrete, or continuous. All right, so 3x squared. We're going to make a little table of values here. Let me start out with, so we're going to do an XY table just to get a few points so we can kind of see what this looks like. Okay, we're just doing a sketch. We're not going to be graphing these very, very nicely. So -2, -1, 0, 1, 2. That's kind of the go-to x values, and then we plug them in. Okay, so if I do -2 squared, that's +4, and then 4 times 3 is 12. Okay, -1 squared is +1 times 3 is 3. 0 squared is 0 times 3 is 0. 1 squared is 1 times 3 is 3. 2 squared is 4 times 3 is 12. Okay, so let's plot these points. So we've got 0, 0. We've got 1, 3. Again, we're just doing a sketch. And then we've got 2, 12. And you'll notice how they mirror each other. So 2, 12 and -2, 12. All right, y'all know what a quadratic looks like. It's got that parabola shape. Kind of looks like a U. All right, so is this a function? That means, does it pass the vertical line test? So if I draw vertical lines, yes, it is a function. Is it one-to-one? All right, so let's go back and look at that definition. One-to-one. Each element in the domain with exactly one unique element in the range. Horizontal line test. Does this pass the horizontal line test? It does not. It's going to cross more than one point. You can see it right here in the table. See how -2 pairs with 12, but 12 is not unique in the range. There's another domain that pairs with 12. Okay, so repeated y values, so it's not one-to-one. All right, is it onto? Is every element in the domain paired up with every element in the range paired up with a domain? Yes, it is. It is onto. And is this discrete or continuous? Are you able to graph this entire graph without picking your pencil up off the paper? You are. So this is continuous. All right, y'all try this one, x equals 7, and then answer all the questions and then see how you did. I'm pause the video. All right, so x equals 7, if we do make a little table just for fun. Okay, you're not allowed to use any other x values but 7 because x has to equal 7. So 7, and then that can pair up with 0, 7 can pair up with -1, 7 can pair up with +1. Basically, all the x's are 7. So if you were to go graph this, you'd have to go over to 7 and then you could go 0, and then +1, and then -1, and then +2, and -2, and that's going to create a vertical line. Okay, so this is something that, oops, this is something you should memorize, really. X equals a number is a vertical line. Okay, Y equals a number is a horizontal line. Okay, now if there's an X and a Y, that's where you're going to get your slopes and your y-intercepts and all that. So this is a vertical line. All right, so is it a function? Well, does a vertical line pass the vertical line test? I would say no, because all of these points are in this set. And so it's passing through really an infinite number of points, so not a function. Is it 1-to-1? Would it pass the horizontal line test? Okay, well, it would, but considering it's not a function at all, we don't really have to answer 1-to-1 or onto. Okay, if it's not a function, then it can't be either one of those, because it has to be a 1-to-1 function and an onto function. So if it's not a function, then it's automatically not those either. All right, but it could be discrete or continuous, because that's not based on function. So can we draw this entire thing without picking our pencil up off the paper? Okay, I'm not drawing it very well, but yes, I can. So this is a continuous graph, continuous relation. So when it's not a function, we call it a relation.